not to some distant star, but into the space between our own ears. A project between Harvard and Google has just given us a map of the human brain like we've never seen before, and it really makes you wonder. It's a wild thought, right? We've got these unbelievable telescopes that can see to the edge of the universe. But the thing sitting right inside our own skull is still, in many ways, a complete mystery. And the reason for that all comes down to scale. The real action in the brain, the stuff that makes us, happens at a level so tiny it's almost impossible to see.
I mean, sure, we've all seen brain scans like MRIs, and they are amazing. They show us which big neighborhoods of the brain light up when we're happy or solving a puzzle. But what they can't do is show us the actual streets and houses. They can't see the individual wires, the synapses, where all the information is actually passed along. And that's where the code of consciousness is written.
To actually read that code, you have to zoom in. I mean, way in. We're talking nanoscale. We need a map that shows every last wire and every single connection. And for that, you need a totally different kind of tool, an electron microscope, which lets us see things that are smaller than a wavelength of light. And that brings us to the HO1 project. This was this massive effort to finally create that map. A team from Harvard and Google got their hands on a tiny piece of human brain tissue from the temporal cortex, and they set out to map every single thing inside of it. And when I say tiny, you won't believe how small it was. The whole sample was just 1 cubic millimeter. That is about the size of a single grain of sand. Now, it came from a patient who was having surgery for epilepsy, which is an important detail, but pathologists confirmed the tissue itself was structurally normal, which means this is the clearest, most detailed look we have ever had at our own wiring.
Okay, so what's inside that grain of sand? Well, for starters, the team found over 57,000 individual cells. You've got your neurons, your glial support cells, blood vessels, the whole shebang. It's like a whole city packed into this microscopic space. Just let that sink in for a second. But here's the number that just blows my mind. The synapses, the connections. Inside that 1 cubic millimeter, they counted nearly 150 million of them. These are the little junctions that make the whole